we're sitting here, we're looking at open. So use the graph to determine open intervals on which the function is increasing, decreasing, and constant. And so what we're going to do is it's saying increasing over what interval. And so we call it an open interval because the idea is this: if we zoom this picture in real quickly, what's happening here as we look at this graph is that as we travel, so we always start on the negative side. So as we travel from negative infinity on the x-axis, and we're traveling across this way, and we keep on traveling across. And so what I need you to kind of be thinking about is as we're traveling across from left to right towards positive infinity, what we're thinking about is saying, like, if I plugged in, for example, -4, right? So if I plugged in -4 for x, I get this spot out right here. So I get -4, -5. And if I plug in -3, I get -3, 0. And if I plug in -2, I get -2, +3. And if I plug in -1, I'm right here. I'm not going up. I'm not going down. I'm at the high point. I'm at the maximum at that spot. And then once I turn the corner at the maximum and I start going down, then I look at this. Okay, so now here I am at x equals 0, and my y value is back at 3. And then here I'm at x equals 1, and my y value is 0. And here I'm at x equals 2, and my y value is back at -5. And so what we're trying to see here is we see two distinctive zones. We see a zone of increase. We see the zone of increase, which is any x value. So, imagine if I was at -5, I would be down here. And if I was at -6, I'd be down here. And if I was at -7, I'd be down here. So this is an interval of increase. My function is increasing. As I travel from left to right, my function values are going up, 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 up until I get to here. So from negative infinity to this particular high point, which is -2 on the x. So remember, 3 is my high point, but the value that determines my high point is the x value. Okay, so that's my increasing interval. And then we go to my decreasing interval. So when I pick up at 2, right, so this is a maximum. So I'm not including 2. So remember we talked about with this idea that a parentheses means not including, and a bracket means to include. So we're using a parentheses when we're saying we're starting at 2, but we're not including 2. And then we start decreasing. So now as my x values keep on getting bigger, my y values keep on getting smaller. I keep on going down and down and down. I went from 3 to 0 to -5 to, say -7, and then to -10, and we just keep on going. And so this is all driven by x, right? So these values that I have listed right here, this would be a decreasing interval. And these values that I listed are x values. X values are what drive the function. Y is what we're looking at. So when we're looking at the up and down, this graph is going up. We're looking at the y values, but we're describing it in terms of x. Here, we're looking at the y values going down, but we're describing it in terms of x. All right, so let me turn this. So it's saying the functional increase. Let's close that. Sorry about that. Which the function is increasing. So my function is increasing. Remember we said from negative infinity, comma, to -2, close parentheses, and we'll test that. Oops. What's that say? Let me clear the screen real quickly. Remember that the function increases in an open interval. I'm going to hit pause and think about what that's saying. All right. Well, I certainly feel silly about this because that particular, I don't know why I said -2. I don't know where I was looking because that's definitely a -1 right there. So I apologize. I erased all that, but you can always go back and rewatch this. But we know, let's go back to red because that was the color I was using. So we know that from negative infinity to -1, we are increasing. So remember, this is x's. So we look at the graph. We're looking at the y values. The y values are going bigger and bigger and bigger and bigger on that interval from there to there, right? However, we describe it in terms of x. So we're saying from negative infinity to -1. That's our interval that my graph is going up. And then at -1, my graph starts going down, and we describe that in terms of x's. And so that my interval would be -1 to positive infinity, and that would be my decreasing interval. So let's try that and see if I did better this time. I don't even know why I saw -2, so we'll change that to a -1. Come down and test it, and that should do it for us. Yeah, that was my error. All right, and so intervals of increase, that's all they're asking. Oh, I continue. So now we're going to ask for the intervals of decrease, and so we just plug in, same thing. So open interval, -1, comma, positive infinity, close parentheses, come over here and check. Awesome. And what else they have for us? All right. And it says, is there any interval of constant? So here's the thing. An interval is going to be more than 1 point. So we do have a maximum. Like remember, so like right here, this is a maximum value on that graph. But it's not an interval. An interval will be something that looks like this, like it goes up, and then it goes flat across, and then it goes down. That right there would be an interval. So from that spot to that spot, that would be an interval. So in this particular case, we're going to answer this question by saying there is no interval of constant. Awesome. And so that gets us through that problem. So once again, just interpreting